All right, so in this video, we're going to talk about the following triangle. And we're going to take this triangle, and suppose we draw 3 dashed lines, each associated with one of the vertices of this triangle. So we have 3 dashed lines, each associated with the 3 vertices of the triangle. And we're going to say that the angles that we're given are these. And the first question is, find the unknown angles. That is to say, what are these 3 angles going to be? Right, just a basic high school geometry question. And we have enough information to figure it out. We know that the sum of these 3 angles has to add to 360 degrees because we're summing angles around a point. So really, if 140 plus 125 plus the unknown angle equals 360 degrees, that makes the unknown angle 95. Right? And now that we know this angle, we have enough information to figure out what this angle is. We know that the sum of the angles in a triangle adds to 180 degrees. So in this case, 17 plus 95 plus the unknown angle adds to 180 degrees. That makes the unknown angle 68 degrees. Same thing for this angle. 23 plus 125 plus the unknown angle adds to 180 degrees. That makes the unknown angle 32 degrees. So at this point, we now have all angles describing this figure. But is this figure even possible? How do we know that this is what the figure looks like? How do we know that we have a triangle that's divided up into exactly 3 triangles? How do we know that these angles do that? Seriously. And you might be thinking, well, obviously, right? That's probably what you're thinking, right? That was good. Because we know that the sum of the angles in a triangle adds to 180 degrees, and all of the angles do that, right? 17 plus 140 plus 23 equals 180 degrees. 23 plus 125 plus 32 equals 180 degrees. 17 plus 95 plus 68 equals 180 degrees. It even holds for the outer triangle. 17 plus 17 plus 23 plus 23 plus 32 plus 68 also adds to 180 degrees. So we're perfectly fine there. Even the sum of the angles around this point adds to 360 degrees, which is exactly what it should do. So what's the matter with this figure? It seems like it's perfectly fine. But let me ask you this. How do we know that these 3 dashed lines all intersect at the exact same point? Well, we know that 2 of the dashed lines are going to intersect with each other, but how do we know that the other dashed line intersects at the same point as the other 2? Maybe this dashed line is angled slightly higher and intersects slightly above where the other 2 intersect. If that were the case, this is what our figure would look like. Right? It's the same outer triangle, and we're going to draw these 2 dashed lines the same exact way as before. But we're going to redraw this dashed line, considering if it intersects slightly above this intersection point. Like that. And it makes sense why this might happen, because this angle is way bigger than this angle. But now it looks a little awkward. In this figure, we have these 3 angles, which all add up to 360 degrees, of course, but it seems that transitioning from here to here, well, these angles go away. But it turns out they don't. All you have to do is extend that dashed line, and all 3 of those angles are still here. In fact, each of these 3 triangles are still here. The only difference is, instead of all intersecting at a point, these 3 dashed lines will intersect to form another triangle. A tiny triangle. But nonetheless, all angles are still here. even the three angles at the center. So this is another possible configuration of these angles. They don't necessarily have to intersect at this point, but rather they could intersect to form a triangle instead. Yeah, geometry can be a bit deceiving sometimes, right? Just by looking at this figure, you can't assume that this is a point that they all intersect at. Maybe it's a really tiny triangle at the center. Well, but maybe it's a coincidence that these three angles all happen to add up to 360 degrees. We know it's true that the three angles add up to 360 degrees around a point, but how do we know that these three angles add up to 360 degrees around a triangle? That seems odd. Well, let's redraw this tiny triangle right here. So this is what our tiny triangle looks like. And again, I'm going to relabel the angles in this triangle. But again, maybe it's just a coincidence that these three angles add up to 360 degrees. But it's not. It turns out no matter what these three angles are, they will always add up to 360 degrees. And we're going to prove that. Let's just call these angles x1, x2, and x3. We want to show that x1, x2, and x3 always add to 360 degrees. And to show that, let's just call the interior angles of this triangle A, B, and C. Now, x1, x2, and x3 are what we call exterior angles of this triangle. And it turns out there's this theorem that says that the measure of an exterior angle is equal to the sum of the measures of the remote interior angles. In other words, an exterior angle is equal to the sum of all angles in the triangle except for the angle that it's adjacent to. So x1 would equal b plus c. That's the way it works. x2 would equal a plus c, and x3 would equal a plus b. And if we were to add all three of these things up, that's the same thing as adding all three of these things together. Notice we have two a's, we have two b's, and we have two c's. We can factor out a 2 from this. And notice that in the parentheses, this is just a plus b plus c. It's the sum of the measures of the angles in the triangle. But we know that the sum of the measures of the angles in a triangle is always equal to 180 degrees. So we can replace this with 180 degrees, but really 2 times 180 is equal to 360. And so there it is. It turns out no matter what these three angles are, they will always, right? They will always add up to 360 degrees. So it's not a coincidence. It is possible to have a setup like this for whatever angles we have here. And so how do we know that this particular combination of angles don't all intersect at the same point? The reason why is because these two dashed lines happen to be angle bisectors of the triangle. An angle bisector is a line that divides an angle into two equal angles, right? So this is an angle bisector and this is an angle bisector because we have two equal angles, two equal angles. These two are angle bisectors, but this one is not an angle bisector. There is another theorem that says that all three angle bisectors of a triangle will intersect each other at the same exact point. So what that means is, if all three of these dashed lines were angle bisectors, then they would all intersect at the same point. But one of them is not an angle bisector, so it has to intersect somewhere else. And since this angle is bigger than this angle, it has to be slightly above that intersection point. And so that's exactly why that happens. So this is the true figure created by these angles, not this, right? So, yeah. Geometry is not just about the numbers that are present in a figure, but it's also about how those numbers create the figure. And so this is basically it for this video.